Okay, so starting with the concept of alpha decay, beta decay, and gamma decay. So let's suppose if we consider the equations of alpha, beta, and gamma. So for alpha particles, so basically in alpha particles, if we consider uranium atom, uranium with 92, 235. So uranium 235, if we just perform the alpha decay or the alpha particle starts to emit from the uranium, so it will split first into the alpha particle, right? Because we are talking about the alpha radiation. So first of all, alpha radiation emits from it, that is equals to the helium nucleus, as we already discussed, two number of proton and four number of nucleons, plus there will be another particle that emits with it. So that will be 90, 231. Okay, because the number of protons that is equals to 2 already taken by the alpha. So 90 will be remaining over there and 231 from the number of nucleons. Okay,
Yes, sir.
okay. And secondly, if we consider the beta particle, so if we consider the beta particle, so if we same consider the uranium 235, uranium 235 92, so it splits into the beta particle plus another element. Okay, this will become 93. Why it will become 93? Because we know that there is an emission of electron. So this 93 can be written as 92 minus minus 1, because there is a negative charge on electron. And due to that negative charge, it will become 93. Okay, clear? Any confusion?
No, sir.
So this is the concept. It will become 93 because electrons emit from there, right? So when electron emits from there, so definitely there will be additional positive charge on it. So that's why it will become 93. Okay. And the third one is the gamma rays. And we know that gamma rays are only the form of energy. So if we consider uranium, again 235, 92, so it will remain same 92, 235 plus energy will release from it, right? So what is the difference between the first uranium, that is before the reaction and after reaction? So the difference between the uranium 92 before and after reaction is that this state of the uranium will be the stable state, right? So this state of uranium will emit in the stable state, right? Clear? Any confusion?
No, sir. But how does it reach the stable state?
Because the additional energy or the extra amount of energy that makes it unstable, right, emits from it during the uh, radioactive reaction. So that's why it will consider as a stable state as compared to the previous state. Okay,
Oh, okay.
so this
Okay,
is the
thank you.
concept. We will further discuss the examples also, because it depends upon, they will not ask like very multiple examples or multiple equations. So we consider with the same one, the same equations. Just for the journal concept, we know that we have to subtract 2 and 4 from alpha, and we have to add 1 in beta, and we don't need to add anything in gamma. Okay. So this is the basic idea that we have to know about in alpha, beta, and gamma. Okay.
Sir, for like when they tell you that, for example, uranium is like decaying or whatever, but how do we know that what other element it's gonna produce?
Basically, it was given in the question that this element decays into this element, so write down the equation. So basically, they want
Okay,
to check that you know about the proper formation of the alpha, beta, gamma or not.
they're gonna tell us the name of the
Yes,
element, right?
yes.
Okay, okay.
So next, because in nuclear reaction, we also get some name of the elements that we got in the nuclear reaction. So first of all, if we discuss the nuclear reactions, so there are two types of reaction. The first one is known as fission reaction. There are two types of reaction, fission and fusion. The first one is, it is a nuclear reaction in which a large unstable nucleus breaks into smaller, more stable. So basically, this is the concept that it will not like completely stable. It will be more stable as compared to the previous state, right? So the radiation that is decaying from that radioactive particle will reduce or slow down. So more stable nuclei releasing energy. Any example in your mind? Okay, let me show you the practical application of this fission reaction. And
It's
you,
used to produce energy, right? Like for electricity and everything.
yes,
Yeah. Light bulbs?
it produces very high amount of thermal energy. Let me show you you all know about that application, but we don't know that this process take place in that specific reaction. So we consider Basically, atomic bomb is the practical application of the nuclear fission reaction, and we also use the same concept in making the electricity from the nuclear reaction. So let's suppose if we consider, okay, so basically this is the documentary on made on the Japan, that is Hiroshima Nagasaki, that was happened due to that nuclear bomb. So if we consider the impact of that bomb also and the working, so now it is dropped from a certain height from the plane, right? And now you can see that how the reaction take place. You have to trigger a neutron. This is a neutron that strikes the nucleus of an atom, right? And it will become more unstable as compared to the previous state. And when it becomes more unstable, so it starts to or the process of the radioactive process will be fast as compared to the previous one. So the rate of radioactive process will be increased. And you can see how much amount of thermal energy is released from this process. So very high amount of energy released from this process. Okay, but this process is not like very safe, that we are not able to perform this experiment in like very openly, just like the other process of windmill and any other reaction to produce the electricity. So we have to perform this nuclear reaction far away from the town or the city, because we know that there are very harmful reactions of the nuclear radiations. You already studied or you already heard about it, that is happening in Japan, Hiroshima, Nagasaki, right? Because it will affect your mutations also, it will affect the cells, and for many years after this incident, they feel and they observe the reactions of that nuclear reactions on their bodies, right? So basically for fission reaction, as you observe in the diagram in the video, that we have to trigger one neutron, right? So that will make that nucleus more unstable as compared to the previous, and that radioactive process will be increase the rate as compared to the previous rate. So basically the reaction is triggered. So reaction is triggered by inserting a neutron, because the uranium is already unstable, and if you strike one more neutron in the nucleus, so it will become more unstable, right? Releasing a more amount of thermal energy and split into smaller nuclei, inserting a nucleus in the unstable. In the nucleus, right? And if we consider the equation or the name of the particle that we get from the equation of nuclear reaction, that is fission reaction. So let's suppose if we take the uranium 92 235. So we take uranium 92 235 this time, and we add one neutron in it. So this is the neutron that we add in the nucleus of uranium. So it splits into, can you identify the element Ba? What is the name of the element? This is barium plus krypton plus three more neutrons. And basically it works like a chain reaction. You observe from this experiment that you will get three more neutrons. And when you are getting three more neutrons, so these three neutrons will help you to continue the process of fission reaction. Okay. So these three neutrons will continue your process. You observe that first we only use one neutron and that produces a very high amount of energy. Then you will get three more neutrons in the result. So that three more neutrons continue the process that will increase by three times. And then when these three neutrons will further strike the nucleus of krypton, barium elements, so they will further split into three, 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 nine neutrons, right? And then again that nine neutrons will further split into three into three into three elements. So you can see that this will continue like a chain reaction. Okay, it will be like 3 to square of the 3. 3 3 is a 9, then 9 into 9 81. So it will split into 81 neutrons, then square of 81 neutrons. So it will work like this. So that's why it will spread very quickly, just like you observe in the video. Okay, any confusion?
No, sir.
And this is the famous equation that we normally use in our questions. Okay, and if we consider one more equation, let's suppose we again use uranium 235 plus neutron. It will split into 54, 144 plus 38, 90 plus neutron. Okay, and if you want to count the number of protons from the left side, that means from the product and reaction. So the number of protons and number of neutrons will remain conserved, right? So left hand side will be equals to the right hand side. Okay. So if you count the number of protons, so you can see on left hand side we have 92 number of protons, and on right hand side you will get the same number of protons. 56 plus 36 will give you 92 again. Okay, clear? Any confusion?
No, sir.
So basically this x is like unknown, so you may just write down the number of x that is unknown, because 92 on the left hand side, and if you add 54 with 38, so what will be the answer you get from it? 80, 88, 92, right? So again you are getting 92 from it. Okay, and if you add the number of nucleons, right, like 144 plus 90, so what will be the answer you will get from this?
234, I guess.
144 plus 90, So you will get 144 plus 90, 234, right? So this is the concept. So on left hand side, if you consider equation number 2, so from equation number 2, we can note down the values like this. From equation 2, on left hand side, we are having 235 plus 1, right? This is the value on left hand side because one neutron is present on left hand side also. So we have to add 235 plus 1. So you will get 26 on the left hand side and you are getting 234 on right hand side. So how many neutrons are less on right hand side?
One.
1 or 2? Basically on left hand side in equation number 2, 235 plus 1. So you will get 236 on left hand side. Okay.
Yeah.
Yeah.
And on right hand side, you are getting 234. So how many neutrons are less on right hand
Oh,
side?
okay, so
Oh
two
yeah.
are left, there's two
Two.
2.
neutrons.
There are 2
Two.
neutrons less. So the value of x will be equals to 2, right? So if you want to find out the unknown value from the equation, so you may just simply find out like this. Okay, count the total number of nucleons. And because we know that we are getting neutron in the result also, so to complete the number of neutrons, you may just take the reference from the values given on the left hand side. Okay,
Okay. So,
any confusion?
no.
Okay,
No, sir.
now one more important question that might be in your mind, that why we are only using neutron in the reaction, right? We are not using proton or electron. So what is the reason that why we are not using proton or electron in the nucleus, striking the nucleus? Because we can use any particle, right, to unstable the nucleus. So why we are only using the neutron in the reaction? So let's suppose if we consider the question is insertion of a neutron is preferred over proton or electron. So the question is why we are using only neutron, not any other element. Any idea in your mind?
Because
Mhm.
wouldn't it neutralize the nucleus?
It will neutralize the nucleus, okay.
I'm
And if
not sure.
okay, if you remember the concept of the Rutherford experiment, so you may take the reference from that, so that will help you to answer the question.
I don't know for electron, but for proton, if it's going close to the nucleus, nucleus already has a plus charge, so it will get repelled anyways. But I
Yes.
don't know for electron.
Yes, so the first point, the first reason is the right one. Very good, because you know that nucleus is already a positive charge. So if we use the positive one, so that will completely repelled by the nucleus. So proton is positively charged, so would feel repulsion and more energy will be needed. So this is the reason that why we are not using proton. And for electron is very small to create enough instability, right? So electron is not enough to create instability in the nucleus. Okay, so this is the reason for electron.